Hello, this is Alex from CloudRF here with a brief tutorial about using 3D tiles on ATAK. If you've used ATAK for a while, you'll be aware that you can load in 3D models in a variety of legacy formats such as OBJ and B3DM. It now, as of 5.5, supports GLB, which is a modern mesh format with lots of interesting extensions. We like GLB over at CloudRF, and so we've been playing with this quite a lot to find out what works and what doesn't, and we'd like to share what we've found out. Here you can see I've got ATAK in front of me. I'm going to load in 3D tiles. Now the toolbox that you've got to load in a model, things like the rubber sheet, which works with the legacy formats, but 3D tiles is for scalable data sets. And the way to get a 3D tiles data set is through the map layers. So you click the map layer and then go to the plus in the corner, and then you drop in your 3D tile source here. Now it does say enter your online source here, so this is for web mapping tiles. It doesn't say anything here about 3D tiles, so it's a little bit of an Easter egg, but if you've seen the Cesium presentation from the ATAK offsite, you'll know that this is where you put the URL. A 3D tiles URL looks like this. It has an address, because it's a network resource, not a local file on the SD card, and it ends with tileset.json. Your URL must end with that because ATAK will check for that. It's not going to load up anything else. It's got to be tileset.json. Okay, so before I load this in, I'll just introduce the data that I'm loading in here. This is what a 3D tiled set file looks like. This one is the new standard 1.1 in which the B3DM format was deprecated. And as you can see, we're now loading up the GLB format, which we mentioned earlier. I like this. It's powerful. This is one of our outputs from our API, and this is just a single tile as opposed to a pyramid of tiles. We're placing this somewhere on the earth. This transform is a little bit complicated at first to get your head round, but this is basically a 3D grid upon the earth, and we have a Python script that converts from WGS84 coordinates into this transform. If you'd like that, let us know in the comments. We can share that, and that will put your model on the earth. As in this case, the volume type is a sphere, so there's different volumes. There's grids, there's boxes. This one's a ball. So let's go and load in our model and see what we get. So we have some layers here. There's one layer. Check the box and click OK, and a model is downloaded. The success rate with loading models in the early days was low. It's got much better. There's more support for formats. If you want to debug why your model didn't load, go and use ADB and grep for models. You'll find some messages in there. But in this case, a model loaded. It's called the name of the path, tileset.json. And if we click that model, we can be taken to that place in the earth, in this case Verona in Italy. So I'm looking at the map here. I cannot see the model. So what I'm going to do is I'm just going to zoom in, and I can start to see something in the middle here. And there we have a 3D model of a house, and I'm just using my fingers to manipulate the map in 3D. And as you can see, I can go around the model, and it's floating in the space, but that's fine. That's where we place the model. It's a 3D voxel around the earth, so you can choose exactly where to put it, even subterranean, but use that with care because you can struggle to see the model once the mapping's over it. And with these models, you can do some interesting stuff. So I could actually go into this model if I wanted to. That was just a Wi-Fi demo for a house. So that's a single file that worked, loading on new GLB format, so we're happy with that. What if I want to scale that up and do an entire city? Well, you can do that. You can stream a very large data set. So where can you get those? Well, the place we recommend is this tool here, BLOSM for Blender. It lets you go and cut 3D tiles anywhere on the earth. Obviously you need to respect the license agreement with the various sources. If you want to find some sources that are public, they offer some public links here, and there's one nice one here, Aarhus in Denmark. It's the older B3DM format, but if you go and grab that link there, you get a good demo. So this demo is, well, we can have a look here. It's a huge file. I'll just explain what's different here. So the version's 1.0, so we're the older legacy format here, but it still works. The geometric error, think of that as a zoom level. That's how far away we are. There's different zoom levels as you go in, different tiles are loaded, and you can see through this file the numbers repeat themselves because we've got different levels, and there's obviously lots and lots of different files here. This should be a good one. So let's go and load that in. So go to the same place we did before. I'll just go and replace that URL with our public tileset.json. There's the Aarhus model, and now we have two models. I'm going to get rid of the one I was looking at earlier because these are memory intensive. Just a word of warning, make sure your phone's got some memory. And now we can see the full path is there, which we can select, and that takes us to Denmark. And now the tiles are loading, they're streaming, and this is exactly why this format is so popular. The data is loaded in a bandwidth efficient format, so I can go ahead and explore the map now. I mean, here's a building, but if I pan out, the resolution drops and you can actually see the tiles building up there, so you can zoom around and look at a much larger data set. Now there's no limit really to how you scale this, it's how much time you've got. But as you can see, it's a very powerful format, allows you to load efficient 3D models over limited bandwidth networks, and the best bit about it is it's all open standards. So if you want to go and learn more about it, a couple of resources I recommend here on BLOSM, and this repository here, Awesome 3D Tiles. It's got a list of viewers, so there's viewers there that you can use to test your data, tile creation scripts, and lots of scripts there to generate the different formats. Word of warning, not all of these work out of the box with ATAK, so you might want to test some of them, but we've had mixed results with some of these scripts. But the point being that so long as your standards compliant, you should work, and there's examples here and here of open standard 3D tiles 1.0 and 1.1 that work in ATAK. Good luck.